Hey there. All right, so this is day one of pre-calculus, and we're kind of opening up with what we call a toolkit of functions. This is the set of functions that I feel like you should be walking in with. This is your toolkit. This is what I know. This is what I'm coming in with. So we're reviewing all the different functions that you would have come across thus far in your math career. We'll add to it here in pre-calculus, but these are the ones that you've seen before. Now, you should hopefully have your toolkit of functions to be doing this with. You can do it in your notes if you want, but you can also, I'm doing your homework for you here. I'm going to do 3 problems. I'm not going to do them in order because I don't want to just do all the easy ones at the beginning and then you have all the tough ones. So I have 3 of them I'm going to do. Let's start with number 5. As we approach pre-calculus, our textbook, the title of our textbook is Pre-calculus, Algebraic, Numerical, and Graphical. Well, so we're looking at math and functions a variety of ways. So let's take a look at the functions that you know in all 3 of these ways. Number 5 here is the square root function. Now you may or may not know what the square root function looks like when you graph it. Hopefully you know what an equation would look like, a square root, what that would look like, but numerically, do you know what happens? Let's take a peek. To start with, the parent function for the square root function, that means the simplest, easiest little square root function you could write, and they give it to us here. It's the f of x equals the square root of x. That's going to be the function that I'm working with. Now, what I'm going to do with that is I'm going to create a table. Even if you know what the graph is going to look like, the table kind of gets us familiar with what happens with the numbers. Now I'm going to plug a number in for x, and then we're going to see what the y equals. We don't want to put negatives in this one. That wouldn't make sense. But I could put a 0 in, and the square root of 0 is 0. I could put a 1 in. The square root of 1 is 1. I could put 2 in, but it's not going to be very pretty, so I'm going to hand pick my values in my table. I'm going to put a 4 in for x. The square root of 4 is 2. Then I'm going to put a 9 in. I get a 3. After that, it's going to go off of my graph. Now let's go over here, and that's what the numbers do. You can see that the numbers are always the square root of whatever the x value was. Let's look at what that looks like on a graph. If I plot those points we just did, there's 0, 0. I don't have very much precision on my stylus here, so bear with me. 1, 1 goes right here. And then 4, 2, and then 9, 3. This graph actually ends up looking like, well, based on the shape of it, it's actually a sideways parabola. Now it's only going to be the top half. The only way to get the bottom half would be to put a plus or minus on my square root of x right here. That's not what it had. That's what they talk about up here. We're just talking about the positive square root. We're not going to do the plus or minus thing. Plus, if you did the bottom half of it, it would no longer be a function because it wouldn't pass a vertical line test. This is your basic square root function. The verbal description of it is the top half. And this is kind of just what you want to write here. Whatever would explain to you when I ask you, hey, what's a square root function look like? And you're going to, oh, it's that top half of a sideways parabola. All right, now, we also, in addition to doing this algebraically, numerically, graphically, verbally, we're going to look at domain and range because that pops up all the time. The domain is the possible x values. So when you look at the graph, you're looking at how far it goes left and right. The farthest left it goes is 0. Since it actually equals 0, we do a bracket. It goes forever to the right, so that's infinity. Infinity is not a number. It's never going to reach infinity, so I do a parenthesis. The range is the possible y values. When you look at a graph, it's the lowest it goes versus the highest. The lowest my graph ever would go is 0, and then it would continually, gradually creep upward also. Now that's a coincidence that the domain and range are the same. That's not always the situation. Let's also look at x-intercepts and y-intercepts. It touches the x-axis at 0. It touches the y-axis at 0. And that's kind of what we want to do. We want to do a quick summary of all the different functions you've seen thus far. Let's try another one. This is the reciprocal function. This is a little trickier. The graph of the reciprocal function, and this is what your reciprocal function looks like. It's a rational. The x is always in the denominator. This is your parent graph. It's as basic as I can make it. But the reciprocal function is actually going to graph like a hyperbola. Now, you did hyperbolas in college algebra. This is a little bit different looking hyperbola. Do you remember what the y equals 1 over x looks like? Let's give it a shot. All right. The parent function is f of x equals 1 over x. So this table is going to get lengthy. I apologize. I know you don't have enough room in your notes. Here we go. You can see I'm going to stretch it way low here. I'm going to start off, and I'm going to start at the very far left of my graph, and I'm going to put in a -10 for x. Now this is the reciprocal function. You're just going to do the reciprocal of -10, or you can put -10 in for x, and you're going to get this -1/10 is what that's going to play out to. All right, I'm going to put in a negative, let's say -2. That's going to be a -1/2. Let's put in -1. That's going to actually end up back to a -1. And then this is what, I put in some extreme values there, the -10. I also want to put in a fraction here. I'm going to put in a -1/2. And the reciprocal of that is -2. And then I'm going to go ahead and finally put in 0. But you can see that you can't plug 0 into this function because you'd have 1 over 0. That's not allowed. Okay, I hope you wrote smaller than I did because I'm really only halfway done with my table. I need to continue this. So I'm going to keep on going. I'm just going to do it over here. You might have to do it in the margin of your notes. I'm going to keep going. So I put in 0. Now I'm going to put in a +1/2. And the reciprocal of that is 2. Put in a +1. Get 1. Put in a +10. How about that? I'm sorry. Yeah, put in a +10. You'd get 1/10. Let's see if we can start plotting. Sorry, that's not going to show up. 1/10. Let's go graph this. Left 10, down a 1/10. I don't even know how to show that. It's just going to be kind of, again, my stylus is iffy, so just, I guess, do yours better than mine. Left 2, down a 1/2. That's not going to look much different, but it's down a little bit more. Left 1, down 1. Left a 1/2, down 2. And then if you could imagine, if I were to have put in a -1/10, I would have ended up down here at -10. So you can kind of see this thing. When they say a hyperbola, it looks like this and goes down this way. All right, now let's keep on going. It says that it can't be 0, so I'm not going to be plotting anything at 0. But then if I put in a 1/2, I'm up at 2. If I put in 1, I'm at 1. Put in 10, I'm at 1/10. Okay, this graph is really the same thing. It's very symmetrical. It would start up here, come down, and then start going this way. All right, and that's what your hyperbola looks like. It doesn't look quite the same as when you did conic sections. It's still considered a hyperbola. It's got 2 branches, and it's approaching these values, these axes, it's approaching those. So those are actually going to be asymptotes. That's why it can't equal that. It's an asymptote going on right there. I would expect you to draw in asymptotes with a dotted line. And it's got a vertical and a horizontal asymptote. Your graphs approach those lines. All right, moving on. Let's go over here to the verbal description. Well, they kind of told us it's a hyperbola. And that's an O. The domain, it goes forever left, and it works its way right up to 0, but it does not touch 0 because there's an asymptote there. So I have that. In union with, that's only the left half of this graph. It picks up again, not quite at 0, but very, very close to 0, goes to infinity. Let's look at the range. This is how low it goes. It starts off, the lowest it goes is negative infinity, works its way up, and it's going to max out at that asymptote at 0 in union with, and then it picks up at 0 and goes forever upward again. So there's your range. Again, happens to match the domain. Coincidence. Last thing, the x and y intercept. Okay, it never touches the x-axis. There's an asymptote there, so we write none. There isn't an x-intercept. There also is not a y-intercept. It does not ever touch the y-axis either. All right, that's the second one. I've got one more that I'm going to do with you. I'm going to do the number 1. Now, you would think this is going to be the easiest one because it's number 1, but it's almost so easy that it's weird. So I thought I'd do a weird one to kind of save you the frustration of what are they asking for? One of the simplest functions is the one where all the x-coordinates are paired with the same y-coordinate. Such a function is called a constant function because the y value stays constant is why that is. Now, they say f of x equals k, but for us to actually do anything, we need to put a number there. Their example says f of x equals 4. So let's do that. F of x equals 4 is going to be the function we work with. And what that means is that it doesn't matter what you plug in for x. You could plug in -3. The y value is always going to equal 4. If I plugged in 0, I would still get 4. If I plugged in 7, I would still get 4. Doesn't matter, my y value stays constant. Let's go look at our graph on that. And can you, so our goal here is for you to look at a table like that and have a visual of what that's going to look like. Now right now we're just refreshing our memory, so we'll go plot it. -3, 4, 0, 4, 7, 4. All right, this is just a nice horizontal line. Anytime your y values all stay constant, that's a horizontal line. It would look like a y equals 4. My verbal description is a horizontal line. As far as my domain and range, my domain, it goes forever left and forever right, so negative infinity to infinity. The range is not that, though. The range is kind of weird because the range is your possible y values. And if you look at your table, your y value is always 4. It's not even an interval so much. I'm just going to say the range is 4. My x-intercept doesn't touch the x-axis, but it does touch my y-axis. I have a y-intercept of 4. All right, I wanted to do 3 of these with you to give you a feel of what I'm looking for. Even if you already know what the graph looks like, I still want the table because we're also trying to analyze what happens within a table. We want to understand all of these different parts of a function. Your homework then is to finish the rest of the functions, every part of the algebraic, numeric, graphical, verbal, and domain range and intercepts. All right, hopefully this gets you started. Good luck.